Right. As a continuation, we are now here in next hop behavior. Before next hop behavior, what we saw is the multi-hop update source. That's all. Now this is the third thing that we are learning. First we saw update source, and then we saw multi-hop. Now we are in next hop behavior. This is this is something looks like a simple topic, but it is not really. There's something very unique which we will see in BGP. The next hop behavior is very unique. BGP is an autonomous system by autonomous system routing protocol. What do I mean by that is, according to BGP's forwarding table, the next hop address to reach the remote destination will not be always the immediate router because it is an autonomous system by autonomous system protocol, meaning it should show the address with which we form neighbor with the next autonomous system. Let me repeat. The next hop will be the address with which we form neighbor with another autonomous system. For example, if I have two different autonomous systems, and on this router, when I learn this 1.1.1.1, when I learn it here, the next hop address will not be the address of R2, but it will be the address of R3. When I learn 1.1.1.1, the next hop address will not be the address of R2, it will be the address of R3. Why? It is an autonomous system by autonomous system routing protocol. BGP is autonomous system by autonomous system routing protocol. So the address that you form neighbor with the remote autonomous system should be shown to every router as the next hop. For example, the address here, let's say 13.1.1.3. The address here is 10.12.0.2. You see this 1.1.1.1, router 3 is advertising to router 2. Router 2 will be advertising to router 1, but when router 2 advertises, the next hop is carried. Meaning the 13.1.1.3 is carried into IBGP. This is the most important. So when R1 learns that 1.1.1.1, when R1 learns that 1.1.1.1, the next stop address will be 13.1.1.3, but actually who is forwarding this packet to R1? R2. The other protocols like OSPF, EIGRP, they will all show router 2 as the next hop. But BGP is showing router 3's address as the next hop. The reason is it is an autonomous system by autonomous system routing protocol. Did you understand this point, what I'm saying?
Yes,
Okay.
I understand this one.
Now let's read from the beginning. BGP is an autonomous system by autonomous system routing protocol. It is not router by router routing protocol. In BGP, the next hop does not mean the next router. It means the IP address to reach the next autonomous system. As I said already, in R1, the next hop to reach 1.1.1.1 will be 13.1.1.3. because that is the address with which we identify the next autonomous system. For eBGP, the default next hop is the IP address of the neighbor router that sends the update. This is the eBGP relationship, no? R2 and R3. For R2, the next hop is going to be what? 13001, 13113. That is normal. The next hop address is also the IP address of the next router. Whereas for IBGP, the next hop advertised by eBGP is carried into IBGP. So you're clear with these 2 points. So these 2 points are very important. Should I repeat, or you're okay with this 2 points?
No, I think it's understand. For eBGP, the default next hop IP address. Yeah, I understand. Yeah. So what I understand, because here I can see R3 is in one autonomous system and R1 and R2 is in another autonomous system.
Yeah.
So basically the IP address information 1.1.1 when it will go into that other autonomous system, basically the left autonomous system is, I mean, R3 router does not have any idea about R1 router does not have any idea about R3. So basically this is the problem happening for next of behavior self it comes out. Is it right?
You're right. You have already gone 2 pages ahead. next up self command. See,
Okay.
you're right. So according to R1, it learns the next hop address which is unknown to R1. See, but I did not teach that one. This line is not teaching that one. This line is not teaching that one, but you have said that one, which is in the next page or the following page. What this line is telling is, this line says, when router 2 advertises about 1.1.1.1 to router 1, when router 2 advertises, it will not put its own address, it will carry the address that it learned from eBGP.
Yeah.
Whatever it learned from eBGP, it is going to carry. So when R1 receives the update 1.1.1.1, the next stop is going to be 13.1.1.3. 13.1.1.3. That's going to be the next hop. Yeah. So, as you said, this next hop address that R1 has received, for R1 it is not unreachable, I do agree, but it's not mentioned in this page. It comes in the next page here. So to change the next hop so that R1 will receive a reachable next hop for R1, instead of 13.113, if it is 10.12.0.2 here, it will be a reachable one. For that, we go here and say next up self to router 1, which is coming next. But my focus here is to tell you that whenever an update from other autonomous system is given to IBGP, the next up address will be the address that is given by eBGP. The next up address
Yes.
advertised by eBGP should be carried into IBGP. Now let's move to the next page. Example here shows the same thing what I have just shown. When router C see router A is advertising this network. A and B have got eBGP relationship. So according to B, what will be the next stop? 10, 10, 10. Now, when B advertises this to C, it keeps the 10, 10, 10, 3. There is no change done to the next hop. As you said, for router C, 10, 10, 10, 3 is unreachable. As a result, router C cannot use the update given from A, which is 172.16.0.0. Router C cannot ping 172.16.0.0. That's true. Router C cannot ping. The reason is the next hop is 10, 10, 10, 3. We don't run any routing protocol in between B and A. So router C do not know about this 10, 10, 10, 3 that it is learning. So what we have to do is we need to tell B to put its own address as the next hop so that C can use the update which came from A to B and B to C. For that, we use the command next hop self. So we need to go to B and say neighbor 172.20.10.2 next hop self. Right. So here is the story. You
Yeah.
see, when the router A's network is advertised, router A is advertising a network called 10.10.0.0.0. This is getting advertised. When it advertises, it puts its own address as the next hop. Usually, this address will be carried to C, but here it is not carried because on router B, this is the configuration that is shown on router B. On router B, we said 3333, which is router C, the next hop self, meaning whenever you send the update to router C 3333, put your own address as the next hop. So what is the address with which you form neighbor? Loopback 0, 2222 becomes the next hop. So when router C receives the update, the next hop is going to be 2.2.2.2. And now, when this update is advertised to a remote autonomous system, again, there's an old story. The next stop will be the exit interface address of this autonomous system because it is autonomous system by autonomous system protocol. So the 2.2.2.2 will not be carried to router D. Why? We just learned in 2 pages before that in eBGP, the next stop will be the next neighbor. In eBGP, the next stop is in eBGP, the default next stop is the IP address of the neighbor router sends the update, which means when router D receives, it will receive this address as the next stop. So do you have any question on this page?
No, that's fine. It's all good from here.
All right. But the next stop behavior story is not yet over. So this is one part of the story. What we have learned here is for IBGP, eBGP given next stop is carried. If that next stop is not reachable, the IBGP routers cannot use the route in the routing table with the unreachable next stop. So to make it reachable, we say next stop self. Next. This is the important story that I want to emphasize. Before I explain this, I want you to go through this. This C and A is not neighbor. Okay? They are not neighbor.
No.
Actually, A learns about the networks of other autonomous system only from B. Because B and A only have got eBGP. So if A needs to learn this network, or also this network, both this network, network 1 and network 2, A can learn only from which one? Router B. But
Yeah.
but if you see, there is a switch here. Otherwise, you cannot connect this three device. There is a switch here. A, when it receives this network from B, it understands that it is coming from 10, 10, 10, 2. But what is router A's neighbor? It is 10, 10, 10, 1.
Yeah.
Router 1, sorry, router A is 10, 10, 10, 3. neighbor is 10, 10, 10, 1. The source of the network is 10, 10, 10, 2, which means we three are in same local area network. It understands that. Who understands? A understands. So A, what
Okay,
it
yeah.
does, instead of going every time through B, going every time through B means what? In the physical relay, in the physical path, if I need to say, it is like this, going here and then going like this. Instead of going like that, because these three are in same local area network, A can go straight to C. A can go straight to C. So the next stop in this scenario will not be 10, 10, 10, 1. It will be 10, 10, 10, 2. This avoids unnecessary hops. So BGP is being efficient by informing autonomous system 64520 of the best entry. What is the best entry to go to 172.30? The best entry is this one, C. Even though C is not a neighbor, the best path is going to be like this. You got it?
Yeah.
This is it. It is because you got these three routers in same subnet. The original source of the network, the advertiser is 10, 10, 10, 2. It comes to B and B is advertising to A. There is no doubt. But BGP is being efficient by informing that autonomous system 520 of best entry. The best entry is to go this way, not like this, which is avoiding unnecessary hops.
Yep.
So router B in 65000 also advertises to 64.
But in the middle of B and C, there is a switch, right?
Yeah, of course. If there is no switch, how can you put them in same VLAN and same
Right,
subnet?
yeah. So the behavior of switch is like to just forward the, I mean, obviously forward the
Yeah,
traffic.
yeah.
So how come it will be filtered
You
that
see, if
option?
A receives the next stop as 10, 10, 10, 2,
Yeah.
then 10, 10, 10, 2's MAC address will be there in the A's ARP table. Using that as the destination MAC address, packet will go here and switch will forward here.
Yeah, it is that. But initially it will send the broadcast, one broadcast, right? Definitely one.
That's different story, yes. That is switching.
Okay. No, no, no. I understand. That's a different one. But it is true that it
Mm,
will send the one broadcast initially.
yeah,
Okay, that's fine. Now I understand. So after that one, definitely A will communicate only with C. Yeah. Now I understand.
right. The next topic is an interesting topic. See, this one we will do lab later. This one and the next top self lab will do later. Let's finish this theory today. Peer group. What is peer? Neighbor. Neighbor group. Whenever we have common configuration to do with multiple IBGP neighbors. See, this is only for IBGP. This peer group concept is only for IBGP.
Yeah.
Whenever there are many neighbors which will have same outbound policy, in that case, we will be using this peer group. Because it is the same outbound policy, instead of repeating that same policy with multiple neighbors, we'll create a template and then we'll copy the template to all the neighbors. So what is the advantage? That makes the configuration simple. That makes the number of lines that you need to create is less. and the updates are generated once per peer group, meaning because you're going to call a template which has got multiple policies, when you call the template, all this will be called once and processed once. If you don't have template, you would have configured this first, process is done. Configure this line, process is done. Configure this line, process is done. Instead, what you do is peer group is a template, meaning you put all of them in one single name, let's say ABC. And when you call that ABC template, you call all of this. So in one go, all this gets processed. That is what it here it says. Updates are generated once per peer group. Let's see an example. You see, this is without peer group. And this is the configuration done on router C. Router C has got 3 IBGP neighbors. One is 24.1, router B, 25.1, router D, 26.1, router A. To all these 3 neighbors, you got similar configuration. This line is same, this line is also same, this line is also same, these 2 lines. So when we have similar configuration to be done for multiple IBGP neighbor, we don't need to do these many lines. You just create a template. This name can be anything. This name can be Ashif. This name can be Ram. This name can be IBGP group, something like that. You just name the peer group. Here they have named it as internal. And then these 4 lines, they have put that 4 lines in that name. And you call that name to these 3 neighbors. See how simple it is. So what is a peer group? Peer group is a template in which we put the common outbound policies. After that, we call the peer group so that all the things that are mentioned inside the template will get processed in one go. Is this clear?
Yes, I'm clear at this point, yeah. Peer group, I'm clear, yeah.
All right. Now, when you're advertising, you need to use the command network to advertise a network. Same like what you did in EIGRP, OSPF. But here, very important thing is, if the network that you have on the interface is classful, you simply say network and then the network. If it is classless, you must use the keyword mask and then the mask, exact mask that you have on the interface. Say, for example, here. This is not the default mask of 192, isn't it?
Yeah.
So you need to use the mask command so that you can have different masks other than the default. And here, this is wrong actually. Here, what they mean is that they should have put 255 here. One here
So
they have.
top one is correct, right? Top.
What? Sorry. So what did you say?
Oh no, it's all
You
good.
see,
It's all right, yeah.
if you will put 1 here and 0 here, it will throw error. Either you should put 0 here, only then it is 24 masks. And there is no need to mention 24 masks. Why? The default 192.168.1 means 24 masks only. This is not necessary.
Yep.
When will you need this? If you want to say 32. If you want to say 32, then you need to, because this 32 is not the default mask of 192. Is this clear?
Yep, it's clear, yeah.
There is something called synchronization rule. Synchronization rule. But the synchronization rule is no more important. There is a
This is not in
it is not
it.
important. It is not important
Okay.
because this is no more active.
Okay.
See here, it is very clearly said. This rule is off by default after the software release of 12.2. 12.2 is very old one. 12.4 was very popular. After 12.4, 15 started. For almost 10 years now we have 15. So, what is this rule? Why it is removed? That is what we need to understand. Why it is removed? What is this rule? Why it is removed? See this diagram. This network, F is advertising to B, and B advertises to A, C, and D. Why? They have IBGP relationship. Do you agree?
Yeah.
Now, if D, C, and A to accept this, I repeat again. If D, C, and A to accept this, meaning to use this or to advertise this to E, they should have a matching route via IGP, meaning if you will have OSPF as a IGP protocol, in that OSPF also someone should advertise this network. Funny. Why will OSPF, which is working inside this organization, needs to have 172.16 update? Not possible. In early days, they were simply doing redistribution, and then they were giving the routes to OSPF, which was unnecessary bad approach. They thought that it is security. How? They thought like this. Okay, when a EBGP gives, we should not simply give to some other EBGP. To guarantee that we can give it, we should have approval from the local. So we should have an IBGP. Now that is what idea. Sorry, we should have route from IGP, which is not possible in today's world. Even in olden days, that is not. It was unnecessary redistribution that they were doing. We try to avoid redistribution. You remember we learned at the beginning redistribution is not recommended. Instead, you need to form IBGP everywhere. But here, even though we have IBGP everywhere, the routes will not be used or advertised if synchronization is on. So this network will not be used by A, C, and D, even though they are receiving it. They will not use it. If they don't use it, they will not advertise it to E. So what I'm saying is this network will be only available in B. It will not be available anywhere else if this rule is on. That is why by default they have turned off. Now there is no problem in using an advertising. Advertisement will now go to E, and E will use it to reach this. If this link goes down, E will reach this path to come. If this link also goes down, E will reach this path to come, because they're all going to use. D, C, and A going to use. There is no restriction when you turn off. That is why it is off. Did you understand the synchronization?
Yeah. Yeah.
So, is there any need to worry about this? No, because this rule is off. All right, so here is some BGP configuration example we'll do in the lab. Now, let's come to this BGP state. BGP, when you configure on one side and if you don't configure on the other side, the neighbor address that you give, BGP will search it in the routing table. During the searching time, the neighbor state will be in a idle. If you type show IP BGP summary, you can see this idle. Show IP BGP summary. And now, when the route is found in the routing table, for three-way handshake, I remember I sniffed the packet and I showed you in the initial days. There was three-way handshake. After that, only open message was sent. For the three-way handshake, the packet will be sent. And if both the side you configure properly, then both the side, the three-way handshake will be done. That makes connect state. Connect state is just, both can do three-way handshake. If both can do three-way handshake, if both the neighbors can do three-way handshake, then only the first message, the open message with the router ID and the autonomous system as a parameter, the router ID and the autonomous system is sent. If the neighbor receives the parameters, accept the parameters, then they go to established state. If something is missing, if something is not acceptable parameter, then they go to active state, meaning it needs to restart from here, idle, from idle state. It needs to restart from idle because something is missing. It will keep trying until you go and do some changes to the parameters. Say, for example, the next stop is unreachable. The packet is coming from some source, and that source is unreachable. Or the packet is coming from some source, that source is not configured as the neighbor. There's some address, there's some difference in the statement that you have configured as a neighbor and the source address from where the packet is coming. So during this active state, you may get something like this message, which is giving you a clue where the problem is. The problem is the autonomous system. Originally, it is coming from autonomous system 10. This is autonomous system 20. Originally, it is coming from autonomous system 10, but here in the neighbor statement, you said, my neighbor is in autonomous system 100. Mistakenly, you put 10. So it says pairing with wrong ace, pairing with the wrong ace. This comes repeatedly every few seconds. When you fix that, then it will become normal. See here, it shows what are the reasons why we see active. The neighbor does not have root to the source IP, or you're pairing with the wrong address, or there is no neighbor statement configured, or the AS number is misconfigured. So active is not good. When your neighbor is established, you should see some number here. In this place, you should not see idle or active. You should see some number, at least 0 you should see. What does this number mean? It means from this neighbor, 8 subnets are received. Prefix received is 8. From this neighbor, 6 prefix received. From this neighbor, another 6 prefixes. 6 prefixes means 6 networks received. All right. So I think we need to continue from here in the next class. We stop here. Do you have any question on this one?
No, up to this, there is no question.
All right then.